Hi class, this video is to help you with topic 5 homework number 6. So I'll write that at the top here. We're doing topic 5 homework number 6. All right, so the problem I'm working through here is the example problem. I'm going to go ahead and make a video to kind of talk you through what is happening. But your problem will look different than this. It will have different numbers, but you're going to follow the same solving process. Okay, so we have Teresa needs $3,500 for a future project. She can invest for a future project. She can invest $2,500 now at an annual rate of 8% compounded quarterly. Assuming no withdrawals are made, how long will it take for her to have enough money for the project? Do not round any intermediate computations and round your answer to the nearest hundredth. Okay, so we have $3,500 we're going to deposit, or sorry, we have $3,500 we need. $2,500 we're going to deposit. We have a rate of 8% compounded quarterly. How long will it take? Okay, so keywords you're looking for here to start with. The compounded quarterly is what is telling us that we are not dealing with simple interest and we're not dealing with continuous compounding. We're compounding quarterly. The other keywords we have here is that she can invest $2,500 now, and that's it. We're not making a payment. We're not making like monthly payments to our account. We're not making quarterly payments. We're doing a one-time payment of $2,500. So this is what tells us we're going to follow our compound interest formula, which is A is equal to P times 1 plus R over N to the NT. When we have this formula, A is always our future amount. P is the principal, so it's the amount we start with. It is that one-time deposit into the account. R is going to be our rate. N is our compounding, and the compoundings are always listed as the number of compoundings per year. And then T is our time. Okay, so we have our formula. Now we want to start substituting in what we know. So the $3,500, that's what Teresa needs. So we want to see how long this will take to grow to $3,500. So we know our A automatically is going to be $3,500. She is investing $2,500. So that is what's telling us that our P value is equal to 2,500. That's what she's investing. That's what she's putting in. She's getting out this $3,500. Our rate, they tell us, is 8%, and we want to go ahead and write that as a decimal, 0.08. And then our number of compoundings, since this says quarterly, we'll assume that's 4 times a year. Quarterly is 4, monthly is 12. All right, and now let's plug all this into our formula. Let's substitute it in. So we get 3,500 is equal to 2,500 times 1 plus that rate over our N raised to the N times T. So the 4 times that T. Notice I didn't write what T was up here. We are looking for how long. So what we're doing here is we're solving for the T. Okay, so we substitute everything in, and you should notice that the T value is in the exponent. When we have a variable in the exponent, the only way to solve is to use logarithms. Logarithms will help us take stuff out of the exponent and bring it down in front. So that's going to be the only way we can solve with this variable in the exponent. Okay, so before we take logarithms, we need to move this 2,500 over. We want to isolate the base of the exponent. So this is our base of the exponent. This is our exponent. We need to isolate the set of parentheses with the exponent. So very first thing I'm going to do is divide by that 2,500. When I divide by that 2,500, I put it in my calculator, 3,500 divided by 2,500. That gives me a terminating decimal of 1.4. So on my calculator, it says 1.4. Since that is what's on my calculator that's listed there, I'm not doing any rounding, so I can go ahead and write the number 1.4. If I were to plug this in my calculator and I got a decimal that is very long, leave it as a fraction. I only did the decimal because it terminates, it stops. In my calculator, I see 1.4. Okay, so we divide the 2,500 over. So we get 1.4 is equal to 1 plus 0.08 over 4 raised to the 4t. Now that we have this parentheses, the base with the exponent isolated, now we're going to take the log of both sides. If you learned natural log, you can take the natural log of both sides as well. Each one will get you to the correct answer. I always learned it as taking the log of both sides, so that's what I do now. But if you learned it as taking the natural log of both sides, that works as well. Okay, so when we take the log of both sides, this is extremely helpful to us because we have this handy dandy log property that tells us the exponent inside of a log. So if we have a log of something raised to the exponent, we can take that exponent and we can bring it out in front of the log and make it a coefficient. So this would become log of 1.4 equal to 4t times log of 1 plus 0.08 over 4. This was the entire purpose of using that log. We can't do anything with the variable in the exponent. We have to get it out of the exponent. The logs are what brings it out of the exponent. So that was the goal of the log, to get that variable out of the exponent. Now that the variable is out of the exponent, I have that t being multiplied by the log and the 4. Now we're just going to solve for that t. So our process now is we're solving for the t. When we do that, keep in mind that log of 1.4 and log of 1 plus 0.08 over 4, those are numbers. They look very complicated, but they are numbers. So we're going to manipulate them like numbers. Okay, so this t, I need to get by itself. The 4 and the log are being multiplied by the t. So what I want to do is I want to divide each side by that 4 and then divide each side by that entire logarithm. So I'd have 4 times log of 1 plus 0.08 over 4. I'm dividing this whole entire thing to the other side. When you're doing this, you want to take everything except for that t and divide it to the other side. So then when I simplify this, my left-hand side I'm going to keep as that fraction. And then on my right-hand side, my 4s are going to divide out and this entire logarithm is going to divide out. So I am left with t. So we took the log, we got the variable out of the exponent, we divided everything except for the variable to the other side. And so now we have what t is equal to. Right now, this is looking very nasty. We have not rounded anything at this point. We are down to our final answer. This is our final answer. So at this point, this is when we break out the calculator. We're going to put it in our calculator in one big chunk. And then this will give us out our answer. And then we will round that answer to the nearest 100. Okay, so when I plug this into my calculator, I'm going to start by opening parentheses, and then I will have log of 1.4, close the parentheses. So if you can see my computer, I have log, parentheses, log of 1.4. 1.4 is in parentheses, and then I close the open parentheses around the log. So that entire thing is in my numerator. And then I'll do the division, open the parentheses again, 4 times log of 1 plus. I open parentheses again for the fraction. I always put my fractions in parentheses. 0.08 divided by 4. Close the parenthesis for the fraction. Close the parenthesis for the log. And then close the parenthesis for the denominator. And then this will give us out our final answer. And so when you do that, when you get out your final answer, you should get 4.2478. And then if we round that to the nearest hundredth, that'd be 2 decimal places. So we get 4.25. 4.25. So it will take 4.25 years. This is our time. It takes 4.25 years to have this money grow to $3,500. So to get from $2,500 to $3,500, it would take 4.25 years.